Next, let's look at piecewise functions. We say that a function is piecewise if there are different rules for what x has to do depending on where in the domain we are referring to. In other words, there are multiple rules that can be followed to determine the corresponding y values. Let's look at the example below. We have f of x is equal to x squared when x is less than or equal to 0. But f of x is equal to just 4 when x is greater than 0 but less than or equal to 2. And finally, f of x is equal to x minus 1 when x is strictly greater than 2. So we have three different rules for three different parts of the domain. To be able to graph these types of functions, we are going to look at one rule at a time. First, let's start with f of x is equal to x squared. We saw earlier that this is the square function, but this is only going to be true when x is less than or equal to 0. Now, if you recall, the square function has a graph that is a parabola. And so when x is less than or equal to 0, we are looking at the part of the graph that falls in quadrant 2. Well, when we square negative 1, we get positive 1. When we square negative 2, we get positive 4. When we square negative 3, we get positive 9, and so on. And so the part of the graph for that first rule would look something like this. Next, let's look at the second rule. F of x is equal to 4. So this is a constant function. The graph of a constant function is a horizontal line. In this case, we're going to follow the rule when x is between 0 and 2, with 0 not included, but 2 included. The line y equals 4 would look something like this. It would go horizontally between 0 and 2. Now 0 is not included, so we're going to use an open circle there, but 2 for x is included, so we'll use a solid circle on the right. Finally, we have the piece f of x is equal to x minus 1. This is a line with a slope equal to positive 1, which is the understood coefficient of x, and with a y-intercept equal to negative 1. Now I'm going to draw the entire line for now, but I'm going to erase pieces of it because we only want this line for x values that are greater than 2. But let's graph the line that has negative 1 as the y-intercept and that has a slope equal to positive 1, which means that we travel up 1 unit, right 1 unit, up 1, right 1, up 1, right 1, and so on. So in essence, the line is going to go like this. But let's erase the part of that line that falls to the left of x equals 2. Now, this is a strict inequality, which means that we actually will need to, I erased too much now. We actually will need to use an open circle here at x equals 2 to say that that point is not included, but then we can include everything to the right. Notice that because this is a function, we cannot have multiple ordered pairs with the same x coordinate yet different y coordinates. In other words, we can't have any ordered pairs that are vertically stacked. So ordered pairs like this one here and that one there, even though they are vertically stacked, one is included in the graph and one isn't. Same goes when we have x equals 0. We have one open dot and one solid dot, so even though they are vertically stacked, only one is truly part of the graph. Now, we're also asked to find the value of the function f when x is negative 3. To know which of the three rules to follow, we have to see where negative 3 falls in terms of the three pieces of the domain. So when x is -3, it looks like we're going to have to use the very first rule when x is less than or equal to 0. So for x equals -3, we're going to have to square -3, which gives us 9. And if we look at the graph, we actually see the ordered pair right here where I'm making that nice and solid. When x is -3, y is +9. Next, let's look at when f is evaluated at x equals 1. When x is equal to 1, we're in the second part between x equals 0 and x equals 2, which means we have to follow the second rule. And in this case, f of x is equal to 4. We see that point here, and I'm going to make this nice and solid. When x is 1, y is 4. And finally, let's look at the third piece, or the third question, I should say. The value of f when x is 5, we would have to look at the third rule when x is greater than 2. So that means we have to follow the third rule. X minus 1 would be 5 minus 1, or 4. And we see that in the graph, when x is 5, the corresponding y value is 4, which I have here in this nice solid red circle. So putting together the graph of a piecewise function means that we have to graph the pieces separately by following the various rules, but by looking very specifically at the parts of the domain that have to follow each of those pieces. Now let's work backwards from the graph of a piecewise function and reconstruct its rules. I actually see two different parts. I'm going to draw the two rules, or separate them, I should say. I'm going to put in this kind of green dashed line to show that one rule will be followed to the left, and then we have a different rule that's going to be followed to the right. So to the left, I see the absolute value function. You can imagine that V-shaped graph just getting cut off where the green dashed line is. So we know that part of the rule will be that f of x will be equal to the absolute value of x. Well, that's true for x values that are strictly less than 2. Why? Because this dashed vertical line has the equation x equals 2, right? Every ordered pair on that dashed green line would have an x coordinate equal to 2. So we're following everything to the left of it, and I see here that this point has an open circle, so that ordered pair would not be included in the graph. Thus why we have a strict inequality here. Okay. Now let's find the second piece to the right. So I'm referring to this piece right here. That looks like a line, and we see that it has a slope equal to -1, because to get from one point to the other, we would have to travel 1 unit down, 1 unit right, 1 unit down, 1 unit right, and so on. So that means that the slope would be -1. And although we don't see the y-intercept, we can imagine that the line keeps extending here and that y-intercept would be at +2. Now, even though that's not part of the graph, if we were to extend the line, that would be the y-intercept. So now if we reconstruct the equation of this line, we would have y equals -x plus 2. The -1 would be the coefficient of x, and 2 would be the y coordinate for the y-intercept. So the second rule would be -x plus 2, and this rule would be followed for x values that are either 2 or greater than 2. And so now we have reconstructed the equations for the piecewise function from the graph.